Welcome to Acosense. My name is Carl, and I'm going to walk you through this presentation and let you know about the basic behind the Acosense instrument, show you some applications and what we've done for others and then potentially can do for you. We are based in Gothenburg, Sweden, with installations so far in Asia, South America and Europe. And what we do is that we are analyzing fluids. And by doing so, we are helping customers to optimize their processes. I will show you examples later, but the basic idea is analyzing fluids and process sections associated with those fluids. All the applications and examples I'm going to show you in this presentation originates from the paper and pulp industry, but if you're from food and beverage or petrochemical or any other processing industry, keep listening because density, viscosity and solid content are equally important for you, of course. But bear in mind that the pictures and examples are from the paper and pulp industry. Here is an integrated mill, and Acosense, we cover most areas in an integrated mill, all the way from the digester, the pulp consistency at the blow line, all the way to the coating of the finished product. So coating color, finalizing the product of the board, from the digestion of wood chips into pulp, all that process. The same thing is for the recovery, chemical recovery plant. So the weakest black liquor to the heaviest black liquor, the recovery boiler, green liquor and white liquor. We cover all that. And the same thing with wastewater treatment plant, where we have several applications. So paper and pulp, we cover basically the entire mill. Coating, starch and color, black liquor, pulp, green liquor and wastewater treatment. Those are the areas we work with. The instrument. The instrument is non-invasive, which means that there is nothing in contact with the fluid as such, which means that there are no wear and tear. So there is minimal maintenance. And at the same time, there is no risk to contaminate the fluid if you're in a sensitive business like pharma or food and beverage. On the other hand, there is no risk for the user, neither during installation nor during maintenance or any other work you perform on the pipe or the instrument. Maybe the most important part is that you can install during full production. So basically what we need is remove the insulation from the pipe and then we can install the instrument, nothing more. A power outlet as well, of course. This is how it looks. So if you zoom in on this one, you can see the small black box on the pipe. That's the instrument. That's Acosense instrument. And this is from the blow line at Cross Pulp Mill. The principle we are working with is called active acoustic spectroscopy, where, to put it short, this is a presentation in itself, but to put it short, we place a speaker on one side of the pipe or the tank, and then a microphone on the other side. And by analyzing the difference, what we let the speaker play to what the microphone picks up, we can add software to analyze those differences and then draw conclusions about the property or the process stage where the instrument is installed. References then. We covered most of the major actors in Scandinavia and also South America. And I'm going to show you two examples and then go through some more application-wise. And that is board and dewatering sludge. So coating a board and adding polymers to wastewater treatment. And together with the customer, we have analyzed that if you follow the coating color properties, viscosity and solid content, you can reduce the number of coating related issues, and you can also shorten the time of the production stop, since you can speed up the troubleshooting and the problem solving due to keeping track on coating. You could exclude that as a reason, or you could pinpoint that the coating actually is the reason. So you can speed up that process, shortening the production stops and minimizing them because you have less coating related issues. So you get more premium board or paper. And in this case, we calculated that up to 100,000 euros per year could be added in revenues, since you get more premium board in that case. For dewatering sludge, or where you add polymers, together with the integrated mill here in Sweden, we investigated that if you're adding polymers based on your actual sludge content at any given time, you can save up to 15,000 euros per month on polymers only. And then you do not calculate on the benefits you get from a consistent, stable sludge content. What does that means for the screw presses or other equipment. So short return on investment on these two installations. This is from a folding boxboard mill where they are analyzing coating color, viscosity and solid content to keep track on the properties of the coating color in this case, to avoid coating related issues and shortening the production stoppages due to quicker or faster problem solving basically. This is from the integrated mill that I showed you before, the example where they have 5 instruments so far: chemical sludge, biosludge and fiber sludge and mixed sludge. The last one is where they are adding the polymers on the mixed sludge part of it. So sludge content basically. Then we have this picture that I showed you before from the blow line where we're analyzing pulp consistency. And within pulp we can also analyze unwanted substances. In this case it's flakes. So if you are having flakes, you would like to turn on a secondary refiner. But if there are no flakes, you would like to save that money or the gigawatts of electricity, since it's a big issue to turn on and off the secondary refiner. So in this case we do not quantify the number of flakes, we just detect presence of flakes by training the system to identify acoustic features only present when there are flakes and not present when there are no flakes basically. I mentioned the black liquor from weak to heavy, and this is the washing liquor going back to the digester, roughly 8 to 12 or so % solid content. Total solid content is worth to mention. We analyze the total solid content. Washing liquor, and then we have the weak black liquor going from the digester to the first evaporation stage. We have intermediate, in this case around 45% solid content, and we also have heavy black liquor. Apart from that, we also analyze the recovery boiler performance or combustibility of the black liquor by, much like the presence or not presence of flakes, we're analyzing huge amount of data with software to analyze how the black liquor behaves or will behave when it enters the recovery boiler. For black liquor, we also have something that we call a scaling indicator. This is not quantifying the scaling progress in millimeters or micrometers. This is a gradually scaling process, so you can base your cleaning cycle on hard data, not your gut feeling, by indicating the scaling progress, like in this case. And then we have green liquor. In this picture, it's density of the green liquor. They have the system where they have 2 pipes, weak liquor going one way and green liquor from the melt dissolver. So yeah, green liquor density in this case. Those are the applications that we have within paper and pulp. And if you want to know more, make sure to drop us an email on info@acosense.com and we will schedule another web meeting or physical meeting when that time arrives. And if you want to contact me directly, you can reach me on carl.nilsson@acosense.com, and you have phone numbers and everything on our webpage, acosense.com. So, thank you very much, and talk to you later.